Evening, everyone. My name is Genevieve, CEO of Smart Solutions. Today, thank you for joining us on our first event of the year, named Leveraging Insights in Data to Catch the 2021 Bull Run. Today, we have our speakers, Tejas, Senior Data Scientist for Smart Solutions, as well as Bao, Investment Director of RE Lee Capital. We will be covering a wide range of topics in terms of how we could be leveraging data, leveraging machine learning, and more importantly, how can we leverage all of this good benefits to catch our alpha run this year. So without further ado, let me share with you a few slides. First of all, I guess 2020 is one of the most eventful year, in a good way, in a bad way. Well, but let's talk about the good positive note. If you look at the S&P 500 projections by several of the investment bank on the list right there, they're expecting a lot of uplift in the next couple of years. So do you believe in that? That's one of the first thought-provoking questions to ask. Secondly, did you know that by leveraging artificial intelligence and machine learning based on records by Statista, it's ranked number 2 in terms of the cumulative forecasted revenue that is going to be generated from 2016 to 2025. And it's ranked 2 and bringing close to 7,000 over million in revenue just by using such algo-based trading strategy for performance improvement. This is even better than prevention against cybersecurity threats, which is one of the biggest thing in the world market with COVID-19. So just a kind of like a thought-provoking 2 slides to begin our event today. So let's start off with our first speaker. I'd like to introduce Tejas. He's our senior data scientist, and he leads the development of machine learning models in our robo-investor fintech product that we have built for our clients. Before joining Smart Solutions, he was a data scientist with a Sense Infosys and a project manager with Accenture, where he managed several SAP large development projects. Tejas received a master's degree in logistics and supply chain management from Curtin in Australia, and he also has a bachelor in engineering in computer engineering from the University of Mumbai, India. So without further ado, I'll let him share the topic, harnessing trends through advanced financial data science. Tejas, over to you.
Yeah. So hello everyone, I'm Tejas, and we'll just go through today the trends, how we can identify trends in a normal financial data science project. So next slide. So today we are going to cover the financial data science project life cycle, how we collect data for the financial projects, feature engineering and feature selection, how we select the machine learning models for the financial data science projects, then the backtest and the forecast and prediction. So the next slide. Okay, so as you see here, there are mainly 3 phases in any data science project. So these are research, analysis, and forecast. Research and analysis takes most of the time in the entire project life cycle. If we break down these phases further, the research basically breaks down into gathering data and preparing data. So basically data is very critical in any data science project. It's the volume of the data, the variety of the data, and the quality of the data, which actually impacts the outcome of the data science project. So when we gather data, we need to keep in mind that we have enough data with us. We have different types of data related to the problem what we are going to solve, and of course the quality of the data. So when we start collecting data, first thing is we need to identify the data sources, right? So there can be different data sources, and the data collected from these data sources can be a structured data or unstructured data. Structured data, as you know, it's a well formatted data in rows and column format, which can be saved in databases. While there is unstructured data, which can be a social media post, it can be a PDF document. So uh, so uh, when we collect data, we need to keep in mind that the data can be in a different format, which we need to do the data harnessing to make sure that this data can be used by the machine learning model, right? So the next step after gathering data is basically choosing a machine learning model. Right now there are different models available, different algorithms available. But when we choose the model, there are certain criteria which we need to focus. The first main thing is the problem what we are going to solve, right? So the problem can be of different type. It can be a classification problem where we are trying to predict the buy sell signals. It can be a problem where we are trying to group the data into different clusters. So when we choose a machine learning algorithm, we need to keep in mind the type of the problem we are going to solve. In addition to that, we also need to keep in mind the volume of the data, because some of the algorithm works very well with less data, but some of the algorithm like decision trees, for example, needs a lot of data to produce a meaningful outcome. So once we choose the model, the next thing is basically whatever historical data we have, we need to divide that data into a training data set and a test data set. So we train the model based on the training data set and test it based on the test data. So that's called the evaluation of the model. So once we test the model, we might have to tune the parameters of the model to achieve the optimum results. So that is called the hyperparameter tuning, which is one of the important process in any machine learning project. So once we have the model once we have a data a harness model identified, tuned for optimal performance, then we can use that model for the forecasting and the prediction. So this is the overall project life cycle for a data science project. Now we'll go into detail of some of these phases. So Jen, can you go to the next slide? Okay. So data collection in any financial data science project, the data mainly comes from four different sources. One is market data, which is nothing but open, high, low, close volume of a particular index or a particular stock, which we are trying to forecast. Then the fundamental data. The points I have mentioned here is from one of our use case, which where we try to predict the try to predict the close value for the commodity index. So in that case, the fundamental data we looked into is the freight data, port data, plant data, and currency data. Then there is a social media and news data. So there are a lot of financial news which we need to which we can incorporate in our training of the model. Then there are social media posts, tweets, or the searches, which can be used in the used as unstructured data in our model. Then there is a financial data like macroeconomic indicator, industry outlook, financial statements of a particular stock, or the stock rating given by the rating agencies. So all this data we can use to predict or to build a model to identify the trend in the stock prices or the index prices. Can we go to the next slide? Okay, all these data are nothing but we call it as features basically. So when we collect different data points, these are the different features which we are going to use in a machine learning project. So why we need to do the feature engineering? So the main first thing we need to do the feature engineering is to make the data set usable, right? So that data set should be usable by the machine learning algorithms, meaning we need to handle the missing values by replacing them with mean or median values, or we need to handle the outliers, right? Sometimes we need to group some of the features into one particular feature, which can reduce the feature dimensionality. So we need to do all these activities to prepare the data for the machine learning algorithms. Second reason why we need to do feature engineering is basically to improve the performance of the machine learning models. Okay, in some cases we need to split the feature. The common example is the date feature, right? So in date, generally we have in date, month, and year format. So we generally split this feature into days, month, days, week, and year to identify is there any specific trend occurring for a particular week in a year, right? So we need to split some features. We need to extract few features from the existing features, or we need to combine features into new features. So all these things we do is mainly to improve the performance of the machine learning model. So if you can go to the next slide. Okay, so here I have given example of which is very typical in any financial data science project. There are technical indicators and momentum indicators which are being used by the investment managers to identify the trends in the stock prices, or how rapidly the stock prices move from one price to another, right? So these are the common indicators which are used. Now these indicators can be derived from the raw data what we collected, that is open, high, low, close volume data. So this is one of the example of feature engineering. So in our Robo Investor platform, we mainly derive around 10 to 12 technical indicators like moving average, exponential moving average, and around 15 to 20 momentum indicators like stochastic, RSI, MACD. Okay, can we go to the next slide? Okay, so once we have all these feature, the next important thing is to select the features. Okay, because it might not be advisable to use all the features we collected, right? Sometimes it happens that some of the feature negatively impact the performance of the model. So it's very important that we need to identify which features can be used to solve our problem, or which features are basically having a positive impact on the outcome of the machine learning model. There are three main techniques which is being used for feature selection. The simplest one is the correlation heat map. It's a visual technique where we try to plot the correlation between different features what we collected. So I have shown one example here. Now, if you can see here, these are all the freight features for one specific use case we gathered. So when I try to find the correlation between these features, there are two features like HHSH freight and QHZGZ freight. These features, there is a correlation of 0.98, which is a very high correlation. So if we include both the features in our final machine learning model, then we might not get the optimal result. So it's always advisable to remove one of this feature and just include one feature into our final set of features for the machine learning model. So this is one method where you can select the features which are important based on the correlation. Then there are a few algorithms which we can use. The simplest one is the select k-based random forest principal component analysis. So these algorithms are basically, some of them are based on the correlation, some of them are based on the feature importance. So these algorithms will try to help you in identifying the top 20 or top 10 features which are affecting to your outcome variable. So we can use this algorithm. The third method is the recursive feature elimination, which I have explained in the next slide. So Jen, next slide, please. Okay. So in this slide, sorry, generally investment manager define different strategies to test to identify the trends. So basically what they do is they select some set of features to formulate one strategy. So as I have shown here, they might create a strategy one with raw market features like open, high, low, close volume plus one technical indicator, one momentum indicator, or a strategy two where they use the market indicators plus one momentum, two technical indicators, or strategy 3 and 4 with market data and fundamental data. So once they have these different strategies, they will test these strategies using the machine learning models, compare the outcome of the models, and decide the final strategy. So in this process, what they are doing is they are trying to identify the best set of features which can be used which can be used for the modeling and the prediction. So this is nothing but a recursive feature elimination, where they can have a different set of features, test those features, and then compare the outcome of these features, and then decide which features are giving you the optimal output. So this is recursive feature elimination. So can we go to the next slide? Okay, so now we have data identified. We also harness the data to make it usable by the machine learning algorithms. Then we identify. Then we did the feature selection. What features we are going to use. So next step is basically identifying the machine learning algorithms. So as I mentioned earlier, there are different criteria based on which you can decide the machine learning algorithm. One is the type of problem what we are going to solve. The second is the volume of the data. So here I have mentioned some of the machine learning algorithms which we are using for a classification problem. What we are trying to do is we are trying to predict the buy and sell signal. So this is a classification problem. So we have a different types of classifiers here. One is linear classifier, which is nothing but a logistic regression or the SGD classifier. Then we have a nearest neighbor classifier, which basically tries to identify the outcome based on the nearest values in the training data. Then we have support vector machines, which is basically a binary classifier which tries to identify whether a particular outcome lies into one class or another. So it's a binary thing. Then there are naive Bayes classifier, which is based on the probability, based on the Bayes theorem, which is nothing but a probability of the outcome. Then we have whole set of ensemble algorithms. So ensemble algorithms are basically a process where multiple models are created based on the different sets of data, and the different features of data, right? So instead of creating just one single model, they create multiple models and try to find out the outcome of those models, and then decide which outcome is basically the best for the final model. So all the decision tree algorithms comes under this particular type of machine learning algorithms, like random forest, extra tree, and the bagging classifiers. So that is one set of algorithms we use. The another set is the artificial neural network. Um, so this is based. These algorithms are based on the neural network methodology. Then there are another algorithm called long short-term memory, which is also a neural network model, but it's a recursive neural network. So it's a RNN type of machine learning algorithms. So these are different algorithms which we can use for the classification problems. Can we go to the next slide? Okay, so now we identified what algorithm we are going to use. So the next step is the backtest. So so backtesting refers to the testing trading strategy on a historical data. This is one of the most important step in any financial data science project, because investment manager need to test the strategies what he is creating to see how these strategies perform on the historical data. So the another important thing is he can create multiple strategies and try to compare these strategies with each other to see which one is beneficial, and tweak the strategies accordingly. So the backtest plays an important role in any data science project, in any financial data science project rather. So, but there is one main limitation for this is overfitting. Now, overfitting is a problem in almost all machine learning models. The thing is, it depends on the historical data. any historical data will have the noise in it, right? So when we try to when we try to use this historical data for training, the algorithm tries to match this historical data very closely, including noise. So the outcome of the test of this machine learning algorithm might be very good, but when you apply this same algorithm on the new data, then that noise might not be present in the new data, right? So in that case, that the same learning algorithm which tested perfectly on the historical data might not give you very good results on the new data set. So this is overfitting, which is generally present in most of the machine learning algorithms. So what we can do is we can try to reduce or try to limit the overfitting. So next slide. So in our back test, we try to limit overfitting mainly by using a walk forward method. So instead of testing entire data set, instead of training model on the entire data set and testing it on a limited data set, what we do is we divide the data set into different batches, right? So instead of so we will have now a shorter batches. So we'll execute our machine learning algorithm multiple times, and then try to find out the outcome for the test period for each set, right? Instead of so basically we divide our entire data set into multiple steps. Now there are two methods where you can use this walk forward. One is anchored and the other is non-anchored. So as you can see, the anchored walk forward is basically always start with the same point of time, right? And the steps gradually, the training steps gradually starts increasing from 10 years to 10 years and 6 months, 11 years, and so on. While in non-anchored walk forward, it's basically a rolling window technology which is being used. So in this case, the training data is always 10 years data, the recent 10 years data, I'll say, and the test data is a 6 months data. So the main difference in this is sometimes we are trying to predict a stock which is very volatile. So the prices are changing very frequently. So in that case, it makes sense to use the latest 10-year data for non walk forward, sorry, instead of using the entire 11 years or 12 years data, right? So this is so there are advantages and disadvantages for both the methods. So we need to so basically which type of walk forward we should use entirely depends on the outcome of the walk forward and the problem we are going to solve. Okay, can we go to the next slide? So okay, so the next slide is pretty simple. Now we have data. We did a feature selection. We identified the machine learning algorithm. We tested our machine learning algorithm with using historical data, and now we have a back-tested trading strategy which works well on the on the historical data. Then we'll use that trading strategy for the prediction. In our case, in one of our use case, we are trying to predict the buy and sell signals. So this is what I've shown here. One thing we try to keep in mind is even if everything works fine, we identified the machine learning algorithm which works well for the historical data, we need to always retest it after few months, because there is always a possibility that we have some additional data in this period, or some of the algorithm might not work well based on the changing data situation, right? So we always need to keep checking our machine learning algorithms and then try to adjust those algorithms accordingly. We might have to gather some more data, or we might have to tune the machine learning algorithms, but that's a continuous process which we should be doing. So that's pretty much it from my side.
Great.
So if you have any questions, please let me know.
Yeah, thanks, Tejas. Any questions from the group with what Tejas have shared? I guess for those that are new to the data science practice, hopefully it gives you a high level perspective of the tedious process it takes, and of course the importance of the data that you're trying to achieve an outcome from. Any questions? We will be taking it either through the chat group, or at any point, if you think it requires some clarifications, feel free to chime in. With no questions, then let's move on to Bao Vu.